let's begin the fun. So the first question that I'm going to take comes from Amanda. So let's go to this question and see what Amanda needed assistance with. So the question reads as follows. It says, find f prime of 0 from first principles if f of x equals to negative x squared plus 2x. So according to what we see here, we know for a fact that we are being asked to find the derivative. This is the first derivative. This is actually how we write the derivative. Don't confuse the derivative notation with the notation for inverse graphs or the notation of inverting a value, the reciprocal. Don't confuse those with the derivative. So what you're looking at here is the first derivative at x equals 0 from first principles. Now, when you see a question like this, you guys should know that we need to obviously use the formula for first principles, and that formula is available in your information sheet. It looks as follows. I want to put it here down so that you guys will see what I'm going to do. The formula is saying the derivative, right, at any x value is always given by, it's always given by the limit, right? It's always given by the derivative of x is always given by the limit as h approaches 0 of what? Of f of x plus h minus f of x, where everything is divided by h. So whenever we hear first principles, what must come to your mind is that we need to use that formula. Sometimes the examiner is not going to say first principles. They might say by definition. So once they say by definition, you guys should know that we're referring to the application of the first principles. Now, when you look at the first principles formula, there are two things that we have on the numerator, right? The f of x plus h part and the f of x part. So we need to find those two and subtract them. If we have them and we can subtract them, then we'll be able to find the derivative when x is 0. Some people might be confused by the 0 that you see there inside the brackets. Don't worry about that. This is the last thing that we're going to work with. That f prime of 0, the 0 that you see there, will be the last thing we substitute once we are done finding the derivative. Now, let's check what is happening here. The good news and the bad news. The good news are we already have this f of x here is what I'm going to replace for f of x on my first principle formula. So it means the only thing that I need to worry about is this part here of f of x plus h. So that's what we need to find. Some people prefer working f of x plus h within the formula. I find it too confusing. It becomes complicated. So I prefer working out f of x plus h somewhere else and not within my first principles formula. So let's see what is that going to look like. So we are looking obviously for f of, not f of x, but f of x plus h. Okay, what does that mean? Well, that means everywhere where you see x, you're going to have to replace it with x plus h. So there's a negative sign there. I'm going to put that. There's an x. I know something must come in brackets for that. There's a square. We've got 2. And then inside the bracket again, we're going to have x plus h. Right, great stuff. Okay. Now, we're going to substitute x plus h everywhere where you see x. So that means we're going to have x plus h here. And we're also going to have another x plus h there. There's a minus sign or a negative sign outside the bracket, so we're going to deal with that later. You have to square your x plus h squared. It's a binomial squared. You guys should be good enough at squaring binomials, and you should know that this is going to amount to x squared plus 2xh plus h squared plus. And then you remove the second bracket. When you remove the second bracket again, you will definitely end up with 2 times x, which is going to give you a value of exactly 2x. And then when you multiply 2 and h, you're also going to get an answer of 2h. So let me remove my arrow there so that this becomes more visible for you guys. So this will give us 2h. From here, we then need to remove the bracket by multiplication with that negative sign. It's going to be negative x squared. And then we're going to have negative 2xh. And then we're going to have negative h squared. It's going to be minus h squared. And then that 2x comes back. And then the plus 2h also comes back. So that is what f of x plus h simply looks like, right? Now that I have those, I'm just simply going to come and substitute them in my first principles formula. This will then mean that we have the limit as h approaches 0 of f of x plus h. What is f of x plus h is all that you see there that we just found. So I'm going to put that in brackets. It is going to be negative x squared minus 2xh. And then there is obviously minus h squared plus 2x plus 2h, close bracket. There's a minus, so I'm going to have minus. Minus all the parts that come from f of x, that obviously comes with a question all the time. And it was given to us as minus x squared plus 2x. So this is going to be minus x squared plus 2x, right? And then everything needs to obviously be divided by h. From here, you then need to remove the brackets. Obviously, this is important for you to put inside the brackets because for some weird reason, you guys never ever take the minus sign between f of x and f of x plus h seriously. This negative sign is very famous for causing you a lot of problems. That is why I'm encouraging you to substitute your f of x inside the brackets. Right. Okay, cool. So let's see what's going to happen when you clean this up. You're going to get negative x squared minus 2xh minus h squared plus 2x plus 2h. Negative times negative gives us a positive x squared. Negative times 2x is going to give you negative 2x. And then everything will definitely need to be divided by h. Now, how do you know that this first principle is going well so far? This is like a hint to help you to understand if you're still doing the right things. All the terms that come from f of x must disappear at this stage, right? Which means what I had, if you look here at the top right corner there, the stuff I had from f of x needs to disappear in this line. Let's just see if that is going to be the case. You will notice that x squared will be cancelled out by minus x squared, and then minus 2x will be cancelled out by 2x. Once this happens, I know that my first principle is going very well so far. And then what is left? Well, we're just remaining with your negative 2xh minus h squared plus 2h, where everything needs to be divided by h. Okay, from here then we apply basic algebra, common factor on the numerator. H appears in all the terms that you see on top, so I'm going to factor it out, leaving inside the brackets minus 2x with minus h and plus 2. Everything still needs to be divided by h. Now, once you are here, you can then obviously cancel the h out. This leaves you with negative 2x, the limit as h approaches 0 of negative 2x minus h plus 2, which we can then express as negative 2x into 0 because our h is tending to 0. As h tends to 0, we will eventually end up with exactly negative 2x plus 2 as our first derivative by first principle. So this is what we are ending up with as negative 2x, right, plus 2. So what we actually expected to get by first principles. But we haven't really answered the question. Remember, we need to find the first derivative when x is 0. So whenever there's a value inside your bracket, do your first principles normally. And then when you're done at the end, only then can you replace your x as exactly 0. So now I'm ready to put my x as 0. I'm going to say I'm looking for the derivative at 0. That's going to be negative 2 into 0 plus 2. And then we eventually end up with an answer of exactly 2. And that is how you find the first derivative from first principles at a particular given x value. Nice question indeed. Right, we're going to move on to the second part of Amanda's question. This one is the one that requires us to use the concept of the power rule. Now remember the following. You guys are very good at applying the power rule because what the power rule essentially says is to find the derivative, you take the exponent, you multiply with the coefficient to get a new coefficient. And then on the old exponent, you just subtract 1. That's all it says, right? So no one can forget that. You guys know exponent times coefficient, exponent minus 1. That is the derivative using the power rule. Now, the reasons why this becomes complicated for you is the algebra part of it, right? You are unable to deal with exponents. So if you find this too much, just go back and double check all the work that you have covered on exponents. You don't know where you can find that on our Tenfold education app. We do have videos on the laws of exponents. They will help you how to work with exponents and how to work with surds because those play a key role when it comes to this. There's nothing that the examiners can trick you on when it comes to this. The only thing that they have, the only weapon they have is exponents. So they actually nail you by using complicated exponential terms that you guys can't be able to analyze. So if you've got problems with that, please go back and check on our app. You'll find all those awesome videos that will help you with your laws of exponents. So let's see what is going on here. We are required to find the derivative of y with respect to x if y is equal to the square root of x minus x squared, where everything is divided by the cube root of x squared. Right. So I'm going to apply a couple of mathematical concepts here to try and simplify this because we definitely need to get all the terms to be in the form coefficient, base, and exponent so that we can apply our power rule. Right. Number one, the first idea I'm going to use is that if you've got a plus b plus c divided by some constant k, right? If you've got 3 terms divided by another k, it doesn't have to be a constant. It could be also any variable or any term of interest, right? You can rewrite that as a over k plus b over k plus c over k. So that's how I'm going to split all my terms here, which means I'm going to have what? I'm going to have the square root of x, right, divided by the cube root of x squared. I'll have minus x divided by the cube root of x. And then lastly, I'll have x squared divided by the cube root of x. Right, so far it is looking good. I've managed to separate the terms into 1, 1. Right. The second idea I'm going to use here to help myself find the solution to this is converting all these surds to exponential form, right? You guys should know whenever anybody gives you something that looks like this. If I give you the 8th root of x to the power of b, you can rewrite that in exponential form, and the exponential version of that will just be x to the power of what was inside the radical sign will be the numerator, and that a there will definitely be what you have on your denominator. So it becomes b over a. So that's what I'm going to simply use as an idea for this particular question. So on top, I've got the square root of x that's as good as x to the power 1 over 2 because there's a 1 inside that radical sign. And then there's a 2 outside the square root sign, even if it's not written. Divided by, for cube root, that's going to be x to the power of 2 over 3. Right. Minus x to the power 1 is fine. On the denominator, I left my squares here and I also left a square there. We're just replicating the same thing 3 times. So that will be x to the power of 2 over 3. And then again, for this one, I'll have x squared divided by x to the power of 2 over 3. Right. I succeeded to convert my terms to exponential form. Now, the next thing to do is to apply basic laws of exponents, which you people should always know. When you're multiplying the same bases, we add the exponent. When you're dividing the same bases, you subtract the exponent. Amanda, I hope this is going to help you to understand what you needed to do here. So let's go and subtract because we are dividing here. So when I'm subtracting here, I'm simply sitting with 1 over 2 divided by x to the power 2 over 3. That's going to be a half minus 2 over 3. If you're not so sure about your subtraction, you can obviously call your calculator and use it to help you to do the subtraction. So I'm simply going to call the fraction here for the numerator. That's going to be 1, right, over 2. I must subtract something. What am I subtracting? I'm subtracting the bottom exponent. And the bottom exponent is simply 2 over 3. So we've got a half minus 2 over 3. That gives us an answer of negative 1 over 6. So that's what I'm writing here. Negative 1 over 6, right, minus. On the next one, you're going to do the same thing again. It's going to be x to the power 1. The top exponent is 1. 1 minus 2 over 3 is the same as 3 over 3 minus 2 over 3. That is going to simply leave you with an answer of a third, minus x to the power of 2, subtracting 2 over 3. You can call your calculator for that if you are not able to do the subtraction by inspection, but just looking at this. So it's going to be 2 minus, right? And then you're going to press the fraction button because the denominator is 2 divided by 3. So you're subtracting top exponent minus bottom exponent. And then it leaves you with 1 and 1 over 3. If you press the change button, this is for those of you who are using the sharp calculator. If you press the change button, it changes it from a mixed fraction to an improper fraction, which is 4 over 3. And that's the one that I want to work with. All right, so 4 over 3 is what we're simply ending up with here. Okay, now this is still y, by the way. I haven't really done my derivative. So that's why this question could have been complicated. Your ability to change it from what it is and then changing, giving each term its own denominator, changing your surds to exponential form, and then subtracting corresponding exponents in order to find the solution to this problem. This is exactly what you guys would need to do because you have to get them to all be in the form coefficient base exponent. So I'm ready now to find my derivative. So I'm going to come here and say, okay, I'm looking for dy over dx. So then I'm going to say now dy divided by dx is exponent times coefficient. That's going to be minus 1 over 6 x to the power of the old exponent minus 1. So minus 1 over 6 minus 6 over 6, that's going to be negative 7 over 6 if you're doing it by inspection. Okay, minus negative 1 times 1 over 3 will give you minus 1 over 3 x to the power of what we have minus 1. which is going to be negative 2 over 3, and then 4 over 3 times negative 1 is going to be negative 4 over 3, x to the power 4 over 3 minus 3 over 3 is going to be 1 over 3, right? Okay, cool. So that's simply what you're going to end up with. Now, normally we want you to have positive exponents. So if you are required to express these terms with positive exponents, just move your variables with the exponents to the denominators so that this thing becomes 6 and x to the power of positive 7 all over 6, and then minus 1 over 3x to the power of 2 over 3 and minus 4. Okay, that one is fine. There's nothing wrong with 4 over 3 x to the power of a third. And this will be the solution to this problem. I hope it has helped you to understand what you needed to do when it comes to the application or the usage of your laws of exponents in order to find the derivative from first principles.